Hello human geographers, we are back at it again. Tonight we are going to be talking about the epidemiological transition model. Now what this is, it's one of our vocabulary terms. It is the distinctive causes of death associated with each stage of the demographic transition. So what I would advise you to do is press pause for a moment, go back, pull up your information about the demographic transition, make sure that you're fresh with that material because it's going to be super important tonight. All right, now the image that you see below is basically the demographic transition model. All right, but what they've done is they've added the different causes of death, those distinctive causes of death for each stage corresponding with the demographic transition. Now, it's important to remember with the demographic transition model, in each stage, the crude death rate is a little bit different. In stage 1, the death rate is high. In stage 2, it declines rapidly. In stage 3, it's declining slowly. Remember we said that stage 3 was growing but slowing? It's because the death rate is slowing down, right? Still declining, but not as fast as it was in stage 2. Stage 4, the death rate is low, and by stage 5, which isn't included on this visual, maybe you could add it to your notes, the death rate starts to tick back up a little bit. All right, to the point where the death rate is higher than the birth rate and you have natural decrease. So let's look at what causes this. All right, so let's take a look at a couple of terms that are associated with the diffusion of disease. Now, the first couple of terms we're going to use are terms that are related to scale, the scale of the disease. So when we hear the term endemic, that's going to be on a more local level. If you hear the term epidemic, it's a more regional level, and especially a large region. If we're talking about a large region of a country or an entire country, a small group of countries, that's what we tend to use the term epidemic for. And then when you hear the term pandemic, that's going to mean it's on a global scale. All right. Then on the other half of the slide, we have two terms that you need to know the difference between. One is vector, the other is non-vector. All right. So vector-borne diseases are carried by an intermediate host. They're passed on by an intermediary that is known as the vector. The way that I like to remember this is that the vector is the vehicle. The vector is carried by, the disease is carried by the vector, it's carried by the vehicle. All right. So for example, we've got malaria. Mosquitoes transmit malaria. Mosquitoes are the vehicle that transmits malaria. They suck the blood of someone who has malaria, what is known as a host, and then the next time they sting someone, it transmits the disease to them, and then they become a host. So this is still contagious diffusion, but it isn't contact between the host and the victim, but rather contact between the host, then the vector, the vehicle that carries the disease, to the victim. All right. Other vector-borne diseases include things like yellow fever, dengue fever, sleeping sickness, which are all, the sleeping sickness is spread by the tsetse fly. Now, there's an interesting article that I read that poses a question, okay, and it's about climate change and the increase of temperature of the globe. And so if the temperature of the globe continues to warm and we see tropical conditions expand, is there the possibility that vector-borne diseases like malaria that tend to be confined to more tropical areas could spread to increased areas? Now, I don't know the answer to that, but it was an interesting suggestion by someone that studies disease. All right. Non-vector diseases are the ones that are transmitted directly from host to victim through contact. The most common vector disease is going to be influenza. All right. The disease often comes from contact with infected pigs, which is often why we get the term, like we heard the term back in 2009, swine flu. All right. And so the disease comes or is contracted through contact with infected pigs. It makes the jump from animal to human. In fact, the biggest pandemic of influenza took place in 1918 and 1919, where somewhere between 50 to 100 million people dwarfs the number of people that died from the Black Plague, died from influenza. It was known as the Spanish flu. There are some other non-vector diseases, things like AIDS, Ebola, MERS, which is MERS, which is the Middle East Respiratory Syndrome. I would anticipate a multiple choice question on this on the AP exam. If they pose a question where they say, which of the following is a vector-borne disease? And they give you 5 diseases, something like that. All right, so now we're taking a look at the different stages of the epidemiological transition model, what we will call the ETM. Now, the person that created the ETM, his name is Abdel Omran. He was an epidemiologist, created it in 1971. That's one of those names that you will want to know, like a Thomas Malthus or an Esther Boserup. There are certain names that you want to remember, and this is associated, again, with the ETM. So we're going to take a look at each stage, what makes up that stage, and then we'll provide some examples. Make sure you add those examples. That's what I'm going to be looking for on this slide, is like the examples of each stage. Okay, so here we go. Stage number 1, if you remember from the DTM, the demographic transition model, has a high death rate. And what Omran noticed is that there are a lot of infectious diseases, parasitic diseases, accidents, animal attacks, things that are largely outside of human control at this point in development. And a really good example of that is the Black Plague, the Black Death, the bubonic plague, whatever you want to call it. We'll take a look at some numbers of what the Black Plague was here on the next slide, but that's a good example of stage 1. Stage 2 is called Receding Pandemics. The crude death rate is dropping dramatically, and so it is receding pandemics. We'll define pandemics later as diseases that have a very wide range, affect a lot of people, and those are becoming less common as the death rate drops. Good example of that is cholera. There are still people today who die from cholera, but the UK dealt with this back in the 1800s. So we're going to take a look at that. All right. The third stage, which was the last stage from Omran, was a stage of degenerative and human-created diseases. Now, we have to clarify what we mean when we say human-created diseases. We're not talking about things like war or murder or biological attacks. We're not talking about that. We're essentially talking about the accumulation of life choices. Think eating at McDonald's every day, or drinking alcohol every day, or smoking every day. All right? As people live longer, those choices start to add up and have a cumulative effect on our bodies. All right, now if you walk into McDonald's and order a cheeseburger and take one bite, are you going to drop dead from a heart attack right there in the McDonald's restaurant? No, probably not. All right, but if you have that cheeseburger every single day, if you drink alcohol every single day, you smoke cigarettes every single day, is the body going to break down? Yeah, it is. All right, so a good example of that is going to be things like, and I kind of already gave an example with a heart attack, things like heart disease, cardiovascular disease, cancer, strokes are probably the most common examples of degenerative and human-created diseases, but also things like pneumonia, diabetes, liver disease are also examples of degenerative diseases. All right? Now, fast forward a little bit, stage 4, the death rate is low. And so S.J. Olshansky and Brian Alt came back and they modified stage 4 just a little bit, and they called it the delayed degenerative diseases. So underline delayed, because now we have the ability to respond to these. We have the ability to address things like cancer and heart disease and diabetes and things like that. All right? People can live longer with these diseases. All right? If someone's diagnosed with cancer, that's not a death sentence. All right? We're able to respond to that, and people are able to beat it. All right? And then finally, stage 5 is going to be the re-emergence of infectious and parasitic diseases. All right, so the death rate ticks back up in stage 5. All right, good examples of stage 5 diseases are going to be things like AIDS, malaria, tuberculosis, H1N1, the flu, re-emerging in areas that might have already passed that. So let's take a look at some examples. All right, so taking a look at this is a map examining the Black Death, and let's do what we typically do. First off, what type of map are we looking at? And this one's kind of tricky. It's not obvious right away. So let's eliminate some options. It's not an isoline map. It's not a cartogram. It's not a graduated symbol map. But if the arrows that you see there varied in size, then it might be. It's not a dot distribution map because the dots represent cities. They don't represent data. So we have to remember that. So I'd probably say that this is a choropleth map. The areas in green are the areas that were affected. And so that's probably what I would classify, but it's a difficult map to look at. And so this is taking a look at the Black Death, the Black Plague, the bubonic plague, whatever you want to call it, in the mid-1300s, all right? And numbers are going to vary depending on what resource you look at, but somewhere in the range of a quarter, so 1/4, to 1/2 of the population of Europe died during this period of time. So we're talking like 20 to 25 million people died from the Black Death, and there really wasn't much that people could do. They didn't know how to respond to this. They had a bunch of different things that they tried. They tried to quarantine people. People moved out to the rural areas again. It didn't matter. They didn't understand what this was. And the reality was that they didn't figure out that the bubonic plague was spread by fleas on rats until the 1800s, during the middle of the Industrial Revolution. Now, it's important to understand that this map doesn't necessarily show it for this particular time period, but the western part of Europe, was actually affected more due to the high amount of trade, while the eastern part was less connected, and therefore there was less contagious diffusion of the bubonic plague. All right. For example, Great Britain's population dropped from 4 million to 2 million during this time. Half. The example that we gave for stage 2 is cholera. And again, we mentioned that cholera is a disease that still impacts people today. We will look at examples in class of people now dying of cholera. But in the mid-1800s, London and Great Britain at the time kind of dealt with it. All right, but let's kind of understand what was happening in London at this time. London was growing quite rapidly during the Industrial Revolution and towards the end of the Industrial Revolution. A lot of people were moving to the cities because that's where the jobs were. And so as the population density increased, remember that we talked about that in our last lecture, we need to see an increase in services, an increase in jobs, an increase in infrastructure, things like sewer lines. Those have to increase as well. But the city wasn't keeping up with the population growth in terms of infrastructure and things like that. So people started to get really sick. So this guy, his name was Dr. Jon Snow, not the guy from Game of Thrones, hypothesized that the water was contaminated. So when you take a look at this map, what type of map are we looking at? It's a dot distribution map. Yeah, there's different sizes of symbols, but notice that it is point data. It is specific to the spot where they're analyzing. And so he noticed that a lot of people were getting sick at the intersection of Broad Street and Lexington. So he went there, he took the handle off of the water pump that was at Broad Street in Lexington, and cholera started to burn itself out. The numbers dropped almost immediately. And so because of the lack of sanitation in London at this time, the water had become contaminated. And Dr. Jon Snow had a hypothesis, he went to it, he tested that hypothesis, and it proved out to be right. Continuing on, remember that stages 3 and 4 are very similar. We talked about how they are degenerative and human-created diseases and delayed degenerative diseases. All right? We said an example for both would be cancer. So what we're taking a look at here are two maps here in the United States looking at cancer mortality between 1950 and 1994. So let's do some 4-level analysis. All right? What are we looking at? We already said it's cancer mortality, and in particular, it's for women. Where is this? It's the United States. At what scale are we analyzing this? Well, this is a choropleth map at the county scale. And when are we looking at it? It ranges from 1950 to 1994. Now, some additional information to help us contextualize what we're looking at. The life expectancy in 1950 was 68.2 years. In 1904, it had increased to 75.7 years. All right. Now, as people start to get older, what we notice is that between 1950 and 1994, what patterns, second level of our analysis, we're starting to see higher rates of cancer. All right. Now, why? Well, people are living longer and the body starts to break down. So what? The fourth level of our analysis. What are some of the impacts? What are some of the effects? What are some of the predictions? Well, we'll talk about that as we move into some of our future lectures. But, think about some of those things. Notice some of those things. Try and predict some of the things that we're going to be looking at. So let's take a look at the top 10 causes of death here in the United States and kind of see where we think the United States is as far as the epidemiological transition model. The leading cause of death here in the United States is heart disease. More than 500,000 people die on an annual basis from heart disease. The second leading cause of death is going to be cancer. Another 500,000 die from that. Then we've got stroke. Stroke, we know, is also a degenerative disease. Chronic breathing and lung disease, that's going to be number 4 on the list. That's also going to be a degenerative disease. All right. And then rounding out the top 5 are not planned accidents. I've always kind of wondered what that is. Like, who plans an accident? Isn't by the very nature of the definition of accidents that you didn't plan it? Anyway, that's number 5 on this list. All right. So of the top 5 causes, 4 of them are degenerative. And that kind of fits because when we looked at the United States and the demographic transition model, they were stage 4. So it fits that the causes of death here in the United States are also stage 4. All right, so let's go ahead and take a look at an example of a stage 5 disease. And I think Ebola is a good one because Ebola really kind of fits with the definition of what stage 5 is. It's re-emerging in more developed countries. It's something that might be more characteristic of stage 2 of the epidemiological transition model, but it re-emerges. It shows up in more developed countries. All right, so let's talk about a couple different examples. What we see in the map here is that the greatest number of outbreaks were in Africa, more specifically sub-Saharan Africa, and even more specifically West Africa. All right, but there were actually cases here in the United States. Hey, there was a Liberian man who flew into Dallas-Fort Worth Airport with the disease, not knowing that he had it. All right, and so we need to bring up the concept of space-time compression again because the reality is 200 years ago, he never would have made it to North America. All right, if he were on a ship sailing across the Atlantic, he never would have made it. He would have died on the ship. Everyone on the ship would have been infected. The ship never would have made it. End of story. All right. But the fact that he was able to get on an airplane and fly across the Atlantic, all right, bringing that disease with him before he even started showing symptoms of it, that is something where stage 5, that's very characteristic of stage 5, and it's a great example of how space-time compression relates to the diffusion of disease. And I actually think that this could be a potential FRQ question. So make a special note about that. They've never asked a question about the epidemiological transition model. Ebola came out, the big outbreak was in 2014, and there have been smaller outbreaks since. And so I think it's something that could potentially be in the pipeline with regards to diffusion, demographics, population, disease, levels of development. So there's a lot that they could talk about with this. All right. So let's make sure that we're prepared for that. Now, one thing that we need to mention with regards to the epidemiological transition model and causes of death, distinct causes of death, is life expectancy. All right, because death and life expectancy are very much connected. All right, life expectancy is generally shorter during stages 1 and 2 of the demographic and epidemiological transition model. All right, and so it's important to understand that when you have a shorter life, the body doesn't degenerate as much. There's not as much time for the body to break down from all of those choices that accumulate over time. Whereas in stages 3, 4, and 5, people are living longer. And so the body starts to break down. They're not dying from animal attacks when they're very, very young. Infant mortality rate is very, very low. And so people are living longer lives. And so the causes of death are distinctly different as people live longer lives. And so that's important. In addition to that, we should also mention that women tend to live longer than men. And we'll actually take a look at this visually in the next lecture when we talk about population pyramids. But women tend to live longer than men. And there's a lot of different theories as to why that might be. And so we'll go over a couple of those theories on the next few slides and show you some images and things like that. One theory is that female fetuses are stronger in utero. There's evidence that there are about 2.5 times more boys conceived than girls. But due to things like prenatal infections, the actual birth rates are closer to 1 to 1. There are still more boys born than girls, but the reality is that on planet Earth, there are more women alive than men. Women are the majority on the planet, and that is because women live longer than men. Another theory about why women live longer than men is that women develop heart disease later than men do. And so that body breaks down later. Another theory, there was a study done by BYU that found that people who have strong social connections tend to live longer, and that women tend to have more social connections, therefore living longer. Though that study did note that there was one exception. Married men tend to have more social ties, and so married men tend to live longer than single men. So I guess all these guys are single. Another theory is that women take better care of their health. Men are 24% less likely to have visited a doctor in the last year than women. Men are 22% more likely to skip things like cholesterol tests. 28% of men don't even have a primary care physician. Those things are associated with longer life expectancy and not cutting a board on your buddy's back. And one final theory is that women are less likely to be daredevils. So all of these pictures, guys, I wasn't trying to offend you. There's actually evidence that women are less likely to be daredevils. We mentioned earlier that accidents were the 5th leading cause of death here in the United States. Well, that's an average, because for men, it's the 3rd leading cause of death. And for women, it's the 6th leading cause of death. So women less likely to be daredevils. They're less likely to, trim the top of a tree with a lawnmower on a crane. They've actually looked at the psychology that might explain this. The frontal lobe in our brain is responsible for things like making responsible choices and calculating risk. And the frontal lobe develops later in men than it does in women. So when guys are making bad decisions, that might be their frontal lobe not being fully developed. So regardless, women tend to live longer than men, and we'll take a look at that in greater detail in our next lecture. I'll see you guys in class. Have a wonderful evening. Good night.